Hello guys, today we are going to discuss zener diode for fixed input voltage and variable load. So let's start. So here when we are going to find VL, which is actually equal to VZ, because these two branches are parallel to each other, and which is equal to RL with an input voltage of Vi. So this is equation 1. So when we solve this equation for RL minimum, what we get? So RL minimum, this is equation second. So let's try to find equation second from this equation. So now so RL minimum is actually equal to, so this is the minimum load resistance for which the diode, a zener diode, is on. So if this is the minimum voltage, what is the maximum current? So the maximum current is actually equal to, so this is the minimum resistance and this is the maximum current, so for which the diode is on. Now so we will tell you first all the equation, then we will start to solve the circuit. So what happens? So this resistance is actually constant, this will remain constant. So how we can find this voltage drop? So this voltage drop is actually equal to this one. So from this equation we can get a, we consider this is a equation 3. So from this equation we can get a VR. So IR here in this case is equal to, this is considered to be equation 4. Now to find the zener current, which is IZ, IR minus IL. Now let me tell you one thing, that for minimum IZ, IL is maximum, and when IL is minimum, IZ is a maximum. But in normal, what happen? In normal, what happen? In normal, what happen? So this current, IZ current, is taken from a table which is considered to be IZM. So for IL maximum, IR minus IZM. So for IZM, IL is considered to be maximum. Now when IL is maximum, so RL maximum will equal to VZ divided by IZ maximum. So these are the equation which can be used in this circuit. So let's start from equation 1. When we are going to find RL minimum, for which the diode is on, R is 1K and VZ is 10 volt, so here, and VI is 50 minus 10. So when we solve this, so RL minimum is equal to 250 ohm. So the first term we found RL, which is equal to 250 ohm. Now, so for RL minimum, for which the diode is on, which is a 250 ohm. Now let's try to find VR. So VR here in this case is actually equal to VI minus VZ. So VZ here, which is zener voltage, is actually equal to 10 volt. So VR is equal to 40 volt. So the second term we found that, which is VR equal to 40 volt, which is equal to 40 volt. Now when we found VR, we can easily find IR, which is equal to now the third term here we found IR is actually equal to 40 milliampere. Now here in this case we do not consider IZ, but we consider IZM, which is fixed and taken from the table. For IZ minimum, for IL minimum, for RL minimum, IL maximum here is actually equal to VL RL and VZ RL minimum. So this is the value. but we do not consider here in this equation now. So we do not consider the IL maximum value. Here we consider IL minimum, because IZ here taken from the table, which is the IZ maximum value. So IZ maximum value here in this case is 32 milliampere. So IR we found is 40 milliampere for IZM 32 milliampere. So the minimum current that flow through the resistance RL is actually equal to 8 milliampere, for which the diode is on. So we found the minimum current that flow through the resistor RL, for which the diode is on, which is actually equal to milliampere. Now, so from this IL minimum we can find the RL maximum. So this is the RL maximum value, the load maximum value for which the diode is on, so which can be find from this equation. So RL maximum is actually equal to 1.25 kilo ohm. So what we can get from this equation? So this equation actually tells us that the RL maximum value is 1.25 kilo ohm, for which the diode remain on. Now for fix 10 volt, what happened? So the minimum voltage for RL is 250 volt, and maximum here is 2.5 kilo ohm. For 10 volt we have minimum RL minimum 250 and RL maximum 1.25k. Now when we plot VL across IL, what happened? So the minimum value here in this case is 8 milliampere, and the maximum IL value is this is IL minimum and this is IL maximum, which is 40 milliampere. So which can be find from this equation, IL maximum is equal to VZ divided by IL maximum. So RL maximum. So RL maximum, RL minimum, which is 250 ohm, which is equal to 40 milliampere. So Iz maximum can be found from this equation Vz and RL minimum. So that's the end of our lecture. Thank you for watching and see you in the next video.